Industrial Vehicles and Safety. Thank you.
Thank you for the intro, Sarah. Can everybody hear me?
Yes.
All right, let's get through that part of it first. My name is Jay Oppenheim. Here in the front row is my partner, Rebecca Mulcarney. We're with a company called Aaron Technologies in Pittsburgh, and for the last 5 years, we have built PIV or forklift collision avoidance products. So we've spent a lot of time thinking about this stuff. We've had a lot of conversations with people over the years about what their machines hit and how and when. And one thing we've learned is that forklifts hit a lot of things. And we're going to get into some of that today. Overview, right, of these conversations we've had. We're going to go over some of the common scenarios. Everybody in this room, it's a pretty full room, so hoping some of you can relate to one or more than one of these scenarios, and just kind of share that information, right? Share what other people are concerned about. From there, we'll talk about how we can use technology to improve these situations, right? So now that you know there's a dangerous scenario, what controls can you implement with what technologies? And then from there, we'll go into data. I think I need to speak up a little here.
Yes.
All right.
Very far room, big room.
All right, so I either have to talk louder or move the microphone higher. All right, so everybody in the back can hear me now? All right, thanks. And then from there, you know, the thing about technology is this gives us access to information. So as we have alerting systems and other things that we can develop and add to our machines, our people, now that gives us access to data. And we'll talk a little bit about how we can use that data that's collected. So it's twofold, right? How to prevent collisions and how to use data. Why do we care about collisions so much? Well, one of the main factors or causes of personal injury due to forklifts are forklifts running into things. Again, forklifts run into other PIVs. They run into fixed objects like racking, and worst is run directly into people. Here's a scenario that's brought to us all too often. It's called, we call it aisle sharing. Here, a person is walking in the same aisle as a PIV, and here we have good line of sight, right? The driver can see the person, and the person doesn't hear this PIV approaching from behind, doesn't see the machine in their peripheral vision, and one of two things can happen. The person can step unexpectedly in front of the machine, or the machine turns, right? And forklifts turn awkwardly on the front wheels, and that machine can clip a person. You hear about this one a lot. So here again, we have good line of sight, but you have some sudden movement of the pedestrian, and the driver doesn't have enough time to react. Similar in forklift lanes of traffic, people can step out from behind obstructions. Here, in this case, we don't have good line of sight. So it's very unexpected. Driver's going along, person steps out, contact happens. Order checkers, this is one of the most complicated and interesting scenarios that we've dealt with, right? You're on a loading dock and there's a lot of chaos. It's a wide open space, you have a lot of congestion, and the last thing that happens before product goes on your truck is you have order checkers or verifiers. So these people are checking the contents of a pallet against a list to make sure that what is on that pallet is supposed to be there. Now at the same time, you have PIVs that are staging pallets. So you have new material coming in behind to be checked, and you have verified pallets being lifted and going onto the trucks. Again, right, they're faced away from traffic, and they're coming out from behind pallets. And just with all the chaos and congestion on a loading dock, it's a very dangerous situation. One that I think we handled pretty well, so I'm looking forward to talking about a solution for that. Doorways, this one's kind of obvious. You open a doorway, if that's a forklift aisle, as soon as you open it, you can't see through that door, you can't see through the wall, so unexpectedly there can be a moving machine on the other side. The nice thing is here, you know that it's a high-risk location, so there's a fairly straightforward way to handle this one. Freezers and coolers are similar to doorways, except instead of people moving in and out, you have machines moving in and out of the room. Now, there's a couple additional challenges that go along with freezers and coolers because of this temperature in the room that has to be maintained. Right, you have to keep food down to a certain temperature, and because of that, machines have to move in and out at speed, right? If not, you lose too much of that cold air, product gets too warm, it's not safe anymore. So you have doors opening and closing quickly, machines moving in and out quickly, and you have that temperature change that can affect sensor systems and cause fog. So similar to doorways, but we'll build on that. Blind corners, again, a fairly obvious one. We can't see through walls. These are high-risk locations that are probably known, and if you have these intersections or corners in your facility, there's probably already a convex mirror there so you can see around corners, but accidents still happen. Cross aisles. Most places we go have things like blue lights now. They were designed for these cross aisles. Right, so mostly it's machine traffic going the long ways in cross aisles, but you do have people and machines going the opposite direction. Now, that blue light is intended to give you some warning, but often that blue light's not seen, and by process you should beep and stop when you come to an intersection, but things happen, horns aren't heard, and you still have near misses and often collisions at these cross aisles. This is like a blind corner, but this one will be handled a little bit differently because even though you know that there's a dangerous location, there's just so many of them that we handle that a little bit different than a blind corner. Staying with racking, in addition to hitting people in cross aisles or hitting other vehicles in cross aisles, you have tight spaces, so PIVs just run into fixed objects. You're trying to make a tight turn, you're trying to take things in and out of racks, and just with those space constraints, things happen. You can't look at this scenario without thinking of that was a viral video a couple of years ago. Every time you tell somebody that you handle forklift collisions, there's these images. I see a couple of smiles in the room where the driver has a slight bump to one corner of a rack. That rack falls, it hits the next one and the next one, and before you know it, the whole warehouse collapses. Shortcuts. Yes, this does happen. You should go to the end of the aisle, turn, and then go down the opposite direction. But there's a temptation there if there's no product filling up that space in your racking. Drivers will see that space, want to go over there, cut through the racking, and a couple of things will happen. They'll either hit that racking, or we've heard more than once now about the posts, right? You have posts that hold up your roof, unexpectedly running into one of those posts while cutting through racking. Unfortunately, the masts of your machine line up nicely with these structural posts. Loading docks. Let's think back to the picking scenario, right? The checkers, where you have these congested loading docks. Here, there's already a heightened level of awareness. You have machines moving in and out of parallel trucks, and a lot of times these machines back out of trucks at the same time and just hit each other. So again, things like basic proximity sensors don't work so well because they would just be alerting all the time. The challenge here with forklifts backing out of parallel trailers is to alert drivers that something is nearby without over-alerting. One driver with 2 specialized forklifts. Admittedly, this one's not a widespread scenario, but it's a true one, so I feel that it's worth mentioning. It was the inspiration for our forklift-to-forklift collision scenarios, and we were hired to solve this one. Well, we had a contract where this company had specialized forklifts, and they would have one driver. They would take a specialized machine with one attachment, do a task, park it, take a second one, forget the first one was there or where they parked it, and then, a few minutes later, run the second one into the first one. So we'll refer to this as the parked PIV scenario. So here the challenge, simply forgetting where you parked your other forklift. So you're aware of all these things. You're aware that your forklifts hit things. You're aware of your high-risk scenarios, where they hit them, and you follow the guidelines. You have nice yellow painted lines around your place. You have yellow railings that physically, you can see them. They divide your machine and your foot traffic. You wear brightly colored vests. You have the projector lights, like mentioned before, right? Give you a little extra warning. So you have blue lights front and back. You have the red curtain lights, so that people know exactly how far back to stand, so that if that machine does spin on its front wheels, they don't get the legs taken out. The blind corners, you have the convex mirrors, so you've done all these things. But, accidents do still happen. So as we continue to add safety measures, add precautions, why do these things still happen? Well, here's some common themes that we've noticed in our many conversations. One is poor visibility, right? You lose line of sight for a lot of reasons. The layout of your facility is one. It's a good thing when businesses grow, you're trying to get more out of your building. But as you become more productive in the same space, you have more blind spots. You have more equipment packed into the same size container, and that can cause poor visibility. The obstructions of the mast on your machine, like mentioned with that shortcut scenario, right? They line up with all the other vertical posts that are in your building, and you can't see things. Some are even wide enough to obstruct a person. PIVs are quiet. Probably more than 90% of the people we talk to these days have electric lifts, so they make almost no noise. You can't hear them coming. And even in the internal combustion machine places, these are often factories with a lot of background noise that drowned out your PIV noise. And the current technology is passive. So while all these things are good, like projector lights and backup beepers and everything else, what we're going to talk about today are some active technologies. So we have all these scenarios. How do we improve each one? So we have, we're going to break it down into the kind of controls we have, and then sensors that enable those controls, and then we're going to put it all together. We're going to match the right combinations of sensors and controls to help fix each of these scenarios. So one thing we can do, intersections. A control we're all familiar with is a traffic signal on roads, right? It tells us when to stop and when it's safe to go. If you know that a forklift is coming one way, we can add lights, right? A traffic signal is a familiar thing. A sign that lights up is going to be better than a static one, right? A static sign that just says danger forklift area, that can blend into the scenery after a while and you forget it's there. So adding a blinking light, adding a gate, right? You can trigger a gate when a forklift comes by that lowers and doesn't let you pass, kind of like a train. And these things are ideal when you have a small number of dangerous intersections and you know the places that you want to treat. You can alert people directly, right? So device to device through some technologies. People can have devices that beep and vibrate and let you know when something dangerous is about to happen. And you have similar equipment that goes onto forklifts themselves. Tells you when a person's too close. You can change a light. You can sound an alarm and let a driver know that a PIV or a person is getting too close. And this is important for people to have alerting devices, because even though people should have the right of way to forklift traffic, everybody knows what happens if a forklift and a person make contact. Doesn't matter who has the right of way, the forklift is going to win. Another control is slowing and stopping a forklift, right? If you have a congested area where you want to control the speed, you can slow that machine down automatically. And if a collision is imminent, you can stop the machine, again, through some kind of engineering control. And finally, we have access control. Access controls are nice because they do a couple of things, right? They confirm who's driving your machine and make sure that that person is trained to do so. And secondly, it provides some accountability. A lot of people we talk to already have systems that do impact monitoring, right? You have to scan your badge, it says who's driving. So if there is an impact, now you know who did it and where and when. Now, you have to know when to activate these controls, like traffic signals, and there's different ways to do that. So one way are radio-based technologies. Some you're already familiar with, like RFID and Bluetooth. These are common radio technologies that can communicate to device. There's also ultra-wideband. This is more of an emerging technology. You'll see it in things even like if you have an iPhone 11 and newer, right? There's ultra-wideband antennas that are emerging everywhere. You can use this technology to communicate point to point. You can measure centimeter level distances quite accurately and make decisions based on that. And because it's an emerging technology, communicates well, non-line of sight, point to point, and it lends itself to hyperlocation, indoor positioning like you would have GPS outside. Another popular system that a lot of people are familiar with are magnetic field generators. So you have systems that create magnetic fields of a certain intensity that creates your warning or your safe zone. And the way these systems work, they appear very similar to radio-based technologies because it's a point-to-point communication. So you have a driver on a vehicle, it's sending out a ping to somebody with a compatible wearable. That ping is heard and it's returned to the driver. And again, it's a nice technology because now non-line of sight, you can literally see through walls and warn somebody that the other is there. Proximity-based technologies, some of these you'll find every day, right? Ultrasonic sensors are like the backup beepers in your car when you're parallel parking. Passive infrared and microwave. These are the things that you find in motion sensors. So trying to build a picture here of how you can use these sensors to enable technologies. So, for example, imagine using a proximity sensor to lower a gate. Now, these don't require tags, but they will alert you to everything, right? You can't differentiate between what you want alerts to and what you don't. And then you have AI-based technologies like cameras and LiDAR. Right? These are attractive technologies too because people don't have wearables, but everything has pros and cons. You don't need to have wearables, but you do need to have line of sight, and you do need to have some intelligence that goes along with camera or LiDAR technology. So let's choose some systems. your system will succeed if it meets these criteria. Right? It has to alert when it's supposed to alert. It has to alert reliably and repeatedly. It can't have false positives, right? This drives people crazy more than anything when a system goes off and you think that there's danger nearby, but it just goes off at random. It has to work in your environment, right? So, like the case of the freezer, if you have big temperature differences, if you have noise, if you have a layout that is, spread out or very confined, you have to have a technology that will work in your environment. If you have a lot of metal, you have to have something that's not susceptible to reflections off of steel or that kind of interference. Has to be easy to install, maintain, use, right? If you have 30 forklifts and you have a system that takes a day to install for each machine, now you're looking at a month before you can even begin to roll out a system and start to get used to it. And it has to not disrupt your current systems, right? We hear about a lot of, especially radio systems, working on common frequencies. So you have things that you've already rolled out that are based on Wi-Fi or some ISM band, and then a new system comes along and completely throws the old one out of whack. So I feel like you have to meet these criteria for any new system to succeed. So which technology, which control can help each scenario? First, the aisle sharing scenario, right? Here, again, we have good line of sight. Our recommendation here would be a radio-based system or a magnetic field generator. The reason being, you need to alert that person that the machine is approaching, right? Proximity-based systems are good for the driver. AI is also good for the driver, but that's more of a one-way alert. And it's good to have these, but this scenario here, we would recommend having those personal alerts as you're approaching from behind. Similar when stepping into the aisle, right? There's an even stronger recommendation to have radio or magnetic field generators in these cases because of the non-line of sight, right? AI can't see around corners, proximity sensors won't see around corners, but with the radio technology or a magnetic field, you can see through those objects. Again, similar here with order checkers, right? You have these people moving around, they're appearing out of nowhere from behind pallets of product. So again, right, you need those two-way alerts. And proximity alerts due to just the complete congestion on a loading dock, we would recommend against here. This one, we're really proud of this scenario with order checkers or verifiers because we did roll out a system with personal alerts, and we got immediate feedback that the people on the ground who are walking around pallets simply didn't realize how many close calls they were having every day. So, we got good feedback that a system implemented in these areas, right? Once you get those gentle nudges, right, a beeper's going off because a machine is coming in behind you. You don't like to hear that. Nobody likes to hear that noise. So it affects your behavior positively, and you start to look out and keep those alerts from happening. So again, we're really proud of that scenario. Right, doorways, right, the kind of control we would recommend here is a traffic light. This way from one side of the wall what's on the other side, and we would recommend you can use non-line of sight technology here to detect what's on the other side of that wall. But in fairness here, you can split apart sensors and lights. So if you have a proximity sensor on one side with a light on the other, that will work pretty well just to let you know what's on the other side. Freezers and coolers, these are similar to doorways, and again, always this non-line of sight sensors paired with some traffic light or lighted sign that lets you know exactly what's on the other side. Here, from what we've heard, cameras will have trouble. So if you have a camera-based technology in a freezer, that is susceptible to fogging, which will affect that sensing. But we did also have some feedback that I guess they didn't become a client, but they figured out a way to use proximity sensors in a freezer because their freezer only had machine traffic, so they knew exactly what they were looking for, and they were able to use those kind of sensors to signal a light. Again, the key there is they knew what was in there. They didn't have to differentiate between people and machines because they knew every time a sensor saw something, it was machine, machine, machine. Blind corners, right? Similar recommendations here. Your control is a traffic light, lighted sign, something that can tell you what's on the other side. Radio and magnetic field technologies, they can be tuned to tell you, do I want to alert to a person coming around the corner, a machine coming around that corner? It's better than motion sensors, which will tell you if anything's coming. We're not very concerned about person-to-person collisions. That's not what's going to do damage, but we really want to know when a machine approaches that blind corner. Cross aisles. This is similar. We need that non-line of sight technology, but we need personal alerts in this case, right? We need those two-way alerts between machines and people because the number of cross aisles are just too numerous to handle the same way as a blind corner or a doorway. Now racking, right? We're going to flip it the other way because racking, there is too many posts to tag, so your radio technologies aren't very good in these scenarios because you would have to tag every single post that you want to have some kind of transmitter or receiver and protect that asset. So here we would recommend a proximity sensor or AI, some kind of camera-based or LiDAR, so that when you're backing into a racking or fixed object, you need something that can detect general nearness. Similar here with the shortcut scenario. Right? It's not very practical to go around and install a radio on every single structural post that you want a forklift to not hit. So you need some general object detection technology to know when you're near these kind of posts. Loading docks, right? So we know this scenario well because we do implement a radio technology. So that's the one we recommend here. We know that radio technologies can be programmed at a very fine level. So here with the loading docks, you can set up your sensors on the back of your vehicles and really only identify when you're going to collide back to back. You can adjust the alert levels too, so that you get more gentle warnings instead of continuous beeping. And the parked powered industrial vehicle, you can handle this one with proximity sensors and AI as well. But we know definitely that you can handle this with radio technologies. Radio technologies are very low power, so even when your vehicle's off, you can draw some current and you can keep that sensor system active. And now finally, right, you have all these single occurrences of places that you're worried about. How do you start to think about designing a system that will fit your whole facility, right? Do you have one system that can handle all these scenarios? Do you piece it together so you have one system for intersections, one for direct alerts? And then you have to ask yourself a number of questions, right? Like what are my main scenarios that I'm concerned about? Let's address those first and then get the peripheral ones second. how many forklifts do I have? How many wearables do I need? And notice, how many wearables do I need is not necessarily the number of people that you have working for you. It could be the number of visitors you expect, or the number of contractors or seasonal workers, if you're not really so concerned about the people that are there every day and know your operation. Number of blind spots. How adjustable is the system? Right? A lot of times you don't get it right the first try. So you deploy a system, it's not exactly as you want it. Can you adjust it on site? Can you make it work for you? Is it tunable? And what are your future uses? Like, is this as far as you want to go with it? You prevent collisions and you're good, or do you plan to build more technology on top of this in the future? Right? Are you interested in things like tracking, utilization, data that you can collect? These are the things to consider when you're selecting a system. Which brings us to data, right? So we have all of these different kinds of systems that we can roll out, right? Whether it's your blind spot telling you that something is encroaching on that area, or your forklifts, or your people, your access controls. We can collect data, right? And data's good. Data gives you visibility. So things that can be collected from these various forklift attachments are impact reports. I know most people are familiar with these. Right? When you hit something, an email is generated. It associates a driver with that level of impact. Inspection status is an important one. Right? You should have daily inspections, weekly inspections, monthly inspections. It's good to know when a vehicle was last inspected. Runtime, right? How often is this vehicle used? What are your hours of runtime? The location of assets, and the near misses, right? How many near misses does a forklift person have? How many warnings? How close are they getting to other dangerous things? And then what can we do with that? Well, one thing that can be done is automate the generation of near-miss reporting and identify your training opportunities. So, right, you should have training after an incident or a near miss, but OSHA recognizes that only about half of actual incidents are even reported, and almost no near misses are reported, because people look at this and think, well, I didn't actually get hit, so no harm, no foul. Am I really going to stop what I'm doing, go fill out a piece of paper, and sidetrack my day? Well, with technology, you can streamline that whole process. If you're already collecting near-miss data on your edge device, some kind of wearable or on the forklift itself, all of those near misses can be offloaded to a cloud site, and that can all be automated completely. Because here, reading through the OSHA documents, near misses are not meant to be tattling or any kind of form of punishment. They're intended to be a tool for process improvement. That's why these near miss collections are important, not to, in addition to identifying risky behavior, but how can your processes improve to fix that? You can analyze traffic, right? You can, right, so now we're collecting near misses on edge devices. If you add in fixed beacons throughout your facility, right? These are gateways that can collect and offload information. Now you've done a couple more things. You've added a couple of key other pieces of information to your near-miss information, and that is when and where did my near-misses happen. So in addition to who, now I'm filling it in. I know who, I know where, and I know when, and we can use that to generate things like heat maps, right? Identify where those high-risk areas are, and now you can move things around. You can reroute your flow of traffic so you don't have near misses anymore. you can locate equipment and people in real time, right? So the same beacons that are installed, the same fixed points that offload data. If you know where and when something happened, you can use that same infrastructure to find things now. So we've been to places where we go to install our system and it actually takes longer to find the forklift than install the system, right? Your places are big, things are moving around, and you end up walking out to find a machine. It's not where you think it's gonna be, and you're kind of chasing it. But by implementing a real-time location system, now you have one more thing you can do, right? Bring up your phone, find out where the desired forklift or person is. Build right on the same system that you're using for collision alerts. Preventative maintenance, right? It's much more convenient to repair or fix your forklift before it breaks down. And you can use things like runtime, right? Runtime is like changing the oil in your car, right? There's scheduled maintenance. How long does that forklift run? Let's do preventative maintenance on it. You can look at how many impacts are absorbed when the last inspection check was done, and you can use all of this information to find out when to conveniently schedule your next maintenance. Additionally, if you look at that same information, you find out that this lift was never inspected or its runtime is very low, you can find out when machines are unused or underutilized, and you can use that same information for preventative maintenance to kind of right-size your fleet. And finally, we can use all of this information to evaluate process change. Right? Everybody is interested in improving, right? So you're spending all this time, all this money to try to improve things. Well, how do you know if that's having a positive or negative effect? Well, we know in some cases, like if you're tracking near misses, you can look at your near miss reporting as the system is rolled out, and you can track that over time. Are my near misses going down? Are my warnings going down? And see a real positive or negative effect, and you can measure it. If you're a company that has multiple sites, you can see what system is working where, and then propagate the successful changes across an organization. So, right, things you should take away from the session today, right? Collision avoidance systems can prevent accidents, right? You need to choose the right technology, identify your scenarios, and choose the right system that'll work for you, right? Do I want a technology that can see through walls, or is that not the right technology for me? And data can provide visibility everywhere from anywhere, right? So think about what data you can collect from your system, how you can use that to drive processes. I think I'm a little short on time here. Would you like to have anything to add?
Not really. I think you covered everything pretty well.
Questions from anyone?
Are your systems, maybe I missed it, but they're customizable? Like you can have multiple systems within inside your plant that would work together?
Yeah, so you can have systems that are customizable by machine or even person,
Okay.
like those kind of things. Right, every single device can be customized to alert when and where you want it.
Okay. So the wearables alert the person that's obviously wearing it, but does the driver get alerted at the same time?
Yes. Yeah, radio technologies provide two-way alerts. We'll be here for a few minutes afterwards if anybody wants wants to stay around. And if there's any other questions from the audience? Thanks, everybody, for coming.
I didn't notice.